Algebra 1 students, welcome to your 7.3 notes. We're going to continue with our idea of how we can simplify exponents. We've got a couple of concepts we're going to look at today. So let's get started. The first one, the big idea that you see over here on the left, it looks like this with numbers. If you have something to the effect of 4 times 3 to the second power, that is exactly the same as saying 4 to the third times 4 to the third, which would be 4 to the 3 plus 3, or 4 to the sixth. Same idea. If you have 3 times 6 to the seventh, you can just simply change that to be 3 to the 6 times 7, or 3 to the 42. So the idea is when you have a power of a power, you multiply the numbers. And remember, that's in contrast to this situation where we had something like, I'll write it up here, 3 to the 6th times 3 to the 7th. That was 3 to the 13th. So in this case, you add. This is different because it's a power of a power. You multiply. All right, so the general form is written down here. The other thing we'll look at is how when you have terms in parentheses, that exponent applies to all of them. We've actually already touched on this just a bit in previous sections, so I'm not going to spend a ton of time talking about it. But the example you see here, 3x cubed to the fourth, we could separate that fourth power, and remember it has to apply to both terms, so you get 81x to the 12th. Alright, so let's do some examples where we practice what we were just looking at. We'll move through these quickly. It's one of those kinds of things that if you understand what you're doing, you do them quickly and you do them right. If you don't get it, you'll probably do them quickly and wrong. Hopefully, you're in the former group rather than the latter. Alright, so a to the sixth to the third is the same as doing a to the sixth times 3, or a to the 18th. Again, a to the sixth cubed means a to the 6 times a to the 6 times a to the 6. Alright, let's take a look at the next one. B to the 8th to the 1/4. This is b to the 8 times 1/4, and we all know that 8 times 1/4 is exactly 2, so that's b squared. Alright, number 3. T squared to the negative 2 times t squared to the negative 5. Now there are a couple ways we could approach this one. What I'm going to do is go ahead and simplify the terms individually, and then we will deal with multiplying them together. So t squared to the negative 2, we could rewrite that as t to the negative 4. T squared to the negative 5 would be t to the negative 10. That's 2 times 5. Now here's where you have to go back to the previous lesson and think just a minute. T to the negative 4 times t to the negative 10. You add those together. So this is t to the negative 14. We've talked about how we don't really like negative exponents much. So we would go ahead and rewrite that one final time as 1 over t to the 14th. Alright, number 4 looks at the second concept we were dealing with. The fact that we have a negative exponent right out here outside the grouping is interesting. Let's go ahead and apply the exponent to everything, and then we'll address that negative situation. So 3 to the negative 4 is the first term, and then we'd have n to the negative 6 times negative 4. That's n to the 24. Now, the interesting thing about that is the two negatives gave us a positive. What we do need to deal with, though, is we have 3 to the negative 4th. So I'm going to have n to the 24th divided by 3 to the positive 4th. And if we're really simplifying here, we might as well make 3 to the 4th 81. All right. Number 5. Again, we have an exponent that's applying to multiple terms. I'm going to go ahead and write this out one piece at a time. That's 2 to the third. X to the 1/6 times 3 would be 1/2, or 3/6. And then finally times x squared. Alright, so again, this is kind of an interesting one where you have a fractional exponent, fun times there. But that doesn't bother us. The reason this doesn't bother us is because we all know that 2 to the third is just simply 8. We can deal with that. And when we do x to the 1/2 times x to the second, that's x to the 1/2 plus 2, or to the 2 1/2. I think it looks a little better if we write it as x to the 5/2. So there it is right there, 8 times x to the 5/2 power. Now that one's a little bit interesting. The fractional exponents, you'll learn some things in future classes where we could adjust that. For now, we're not going to worry about it. All right, though, we have one more to look at, another similar one where we have exponents applying to multiple places. So I'm going to apply this -1 to both terms here. M to the -1, G to the -4, and then we'd have M to the 4 and G to the 4. Okay, now this is interesting because, well, the first term's not too bad. M to the -1 times M to the 4, that's -1, plus 4, that's M to the third. Here's the part that's interesting. G to the -4 times G to the 4, that's the same as G to the 0, -4 plus 4. We all know that G to the 0 is just simply 1, so we would just write that as M cubed, M to the third, because we would not like to leave something like G to the 0 in our problem. All right, let's continue on. If you don't have a calculator handy, you might want to pause the video for just a moment and get one. Although you don't need one on 7, you might want one on 8 and after that as well. So 3 times 10 to the 5th. Scientific notation, fun times. Quantity squared. Now the rules are the same, so let's take a look at this. That means you'd have 3 squared times 10 to the 5 times 2, so that's 10 to the 10th. And 3 squared is 9. We can go ahead and write it using the x as our scientific notation like we're used to. And there it is, 9 times 10 to the 10th. Now we want to keep these in that scientific notation. All right, the next one requires a little bit more math. I'm using my calculator as we speak. I'm getting 2.37 to the third. Let's color code this thing. Here we go. That's looked better. 2.37 to the third times 10 to the -4 times 3, that's going to give us -12. Now obviously we don't need the calculator for 4 times 3, but probably most of you don't know 2.37 to the third power. I know I had to punch that in myself. Confessions of a math teacher. Okay, 13.312053. You probably don't have to put quite that many digits, but I'm going to roll with it. And that looks great, except we know when we're doing scientific notation that first number needs to be somewhere between 1 and 10. 13 does not fit that mold. I need to move that decimal, so I'm going to rewrite this as 1.33. I'm going to go ahead and abbreviate that just a little bit. That's good enough for me. If I'm making this number bigger, and I said that backwards, I actually made that number smaller, didn't I? 13 to 1.3. I better make that number there bigger. Now here's where you have to think a little bit. What's bigger than 10 to the -12? That would be 10 to the -11. -11 is 1 bigger than -12. It's nothing crazy, but you have to think. It's easy to make silly mistakes. All right, this, I believe, would be the end of the notes, the last 2 problems right here. That is confirmed by my quick check on the side. So let's take a look at this. Now, what I'm going to do, I'm going to put a little variable in here, just so I'm going to use the letter A. You can put that if you want, or you can just think through this. But here's what I know. This is a power of a power. X to the A to the third. That means A times 3 has to equal 15. That's the only way this statement can be true. So we know 3A is 15, and then of course divide, and we would know that A is equal to 5. All right, and now to the final problem. Y to the 7th, and we have a box here where we're having to determine. I'm going to put an X there because I know that 7 times X would give me my exponent on the left-hand side. So 7x would equal the exponent over here, which is just simply 5. And we divide, we get x equal to 5/7. Yeah, I know it's not an integer, it's some weirdo fraction, and I'm totally okay with that, and I hope you are too. Hey folks, I hope you've gotten the two big concepts here. The first one, of course, being power of a power means you multiply. The second one, when you have an exponent outside parentheses, it applies to everything within that group. Apologies for my horrible sounding voice, but I am more interested in you learning math than me sounding good. Hopefully we've accomplished that today. Have a spectacular one. We'll see you soon.